Hi students, welcome to my lectures on mechanical unit operations. Today we are going to discuss a very important topic, which is conversion of force from one unit system to another, because this is a bit tricky, okay, because different countries used to follow different unit systems. They have defined the forces in different ways, okay. Because of this definition of a force, okay, it is not easy for us to convert in as simple way as possible, even though if you surf the internet, and it will be most confusing way, okay. Today I am going to discuss about conversion of force from one unit system to another using very simple method. If you follow this method, you never going to refer any books and for more reference. And the second, apart from the conversion of forces, I am going to explain you about the pressures, because soon we are going to deal with the forces and pressures in my lectures. So I thought better to give a clarity on conversion, because in the older books, because in the referred books, sometimes people mention the kg force, poundal force, dyne force. So in such cases, we have to be very clear about our basics, then only we can able to convert and understand, because in different force units, because these days people primarily follow as an international system of units, SI units, okay. And so in some older books, if you see any LB force or poundal force or the dyne force, you should not get confused. What you should learn is how to convert the other forces into the international system of units, okay, newtons for example. Today our lecture talks about converting everything in terms of newtons. The first basic thing you all have to remember is how the force is defined by in different unit systems. If it is MKS or SI, FPS unit system or a EE unit system, there are many unit systems that are existing, okay. But today these days primarily follow SI system of units, so you don't need to worry, but still you have to learn, okay, how the different system of units people follow. So let us go further, and let us start with 1 Newton force. Typically 1 Newton force people follow, in SI system of units people define what is 1 Newton force. 1 Newton force means 1 kg into 1 meter per second square. What this exactly mean? Imagine I have the 1 kg mass with me. If I have to throw this mass, because at a acceleration of 1 meter per second square, then I have applied 1 Newton force. That means 1 kg if I hold, throw it at an acceleration of 1 meter per second square, that means I have applied 1 Newton force on this 1 kg mass. That is how the 1 Newton force is defined. Let us go to the next, kg force. Typically in MKS unit system, you might get this, what is the kg force? It is very simple, stick to definition. All that, this is because I have given the tick mark, means it's a definition, that is how the people defined, okay. 1 kg force is 1 kg into 9.8 meter per second square. What means is, if I have 1 kg in my hand, I throw at an acceleration of 9.8 meter per second square, that means I have applied 1 kg force on this particle. That is why 1 kg force is equal to 1 kg into 9.8 meter per second square. Let us convert to newtons. What is 1 into 9.8? 9.8. Okay, 9.8 into 1 kg into 1 meter per second square. What is 1 kg into 1 meter per second square? Is nothing but 1 Newton. That means now 1 kg force is nothing but 9.8 newtons. What is the other way? What is 1 Newton? Is nothing but 1 by 9.8. Okay, 1 Newton is nothing but 1 by 9.8 kg force. That means 0.102 kg force. This is how you can convert kg force to Newton or Newton to kg force. Let us see how the pound force is defined, LBF, pound force. What is 1 pound force is equal to 1 lb into 32.174 feet per second square. This is how people have defined it, okay. That means if I have 1 lb mass with me, I have to throw this 1 lb mass at an acceleration of 32.174 feet per second square. That means I have applied 1 lb force. Let us convert this lb force to the Newton now. 1 lb force is equal to 1 lb. What is 1 lb? Is nothing but 0.453 kg. What is 30? Because I have to convert feet to meter now. 32.174 feet is nothing but 9.8 meter. Feet to meter. Now what is 0.453 into 9.8? Is nothing but 4.439 into 1 kg into 1 meter per second square. What is 1 kg into 1 meter per second square? Nothing but newtons. 1 newton. That means 1 lb force is equal to 4.439 newtons. What is 1 newton? Is nothing but 1 by 4.439, which is nothing but 0.225 lb force. Okay, this is how to convert newton to lb force to newton. This is how people define PDL, pound-all force. What is a pound-all force? Is nothing but 1 lb mass into 1 feet per second square. If I throw 1 lb mass at an acceleration of 1 feet per second square, that means I have applied 1 pound-all force on this particular mass, 1 kg mass, okay, pound. That means 1 PDL is equal to 1 lb. What is this 1 lb? 0.453 kg. What is 1 feet? Nothing but 0.304 meter. That means if what is 0.453 into 0.304 is nothing but 0.137 into 1 kg into 1 meter per second square. What is 1 kg into 1 meter per second? 1 newton. That means 1 pound-all force is nothing but 0.137 newton, which is 1 newton is equal to 7.299 pound-all force. And similarly, how the dyne force is defined. 1 dyne force is equal to, if I have 1 gram, this is 1 gram, I have throw this 1 gram at an acceleration of 1 centimeter per second square. That means I have applied 1 dyne force on this particular 1 gram mass. 1 dyne, let us convert to the newtons. 1 dyne is equal to 10 power minus 3 kg, because 1 gram is equal to 10 power minus 3 kg. What is 1 centimeter? 10 power minus 2 meter. So 10 power minus 3 into 10 power minus 2 is equal to 10 power minus 5 into 1 kg into 1 meter per second square. What is 1 kg into 1 meter per second square? It is nothing but Newton. That means 1 dyne is equal to 10 power minus 5 Newton, or 1 Newton is equal to 10 power minus 5 dyne. This is how you can convert dyne force to Newton, Newton to dyne force. So if I collect all the, let us define what is 1 Newton. 1 Newton is nothing but 0.102 kg force, wow, which is equal to 0.225 lb force, which is equal to 7.299 pound-all force, which is equal to 10 power 5 dyne. That is what it has been written on this particular board. Okay, using this conversion formula, you don't need to worry about, you need to learn definition, how the kg force is defined. Is it 1 or 32 feet per second square? Okay, if you remember these basic definitions, how people have defined, rest everything is nothing. Okay, this is how you can convert newtons to kg or kg to newtons. You can convert any force to the Newton force. Let us solve a small example so that it will be more clear. What is the lb force required to throw an iron plate of 2 kg at an acceleration of 15 meter per second square? That means I have to find out the pound force, okay, lb force. Okay, I have mass which is 2 kg. I have to accelerate at a distance of, I have to accelerate at a 15 meter per second square. Okay, I have to throw, okay, I have 2 kg, I have to throw at an acceleration of 15 meter per second square. Then how much pound force is there? I have applied on this particle. Okay, then F equal to m into A, which is called 2 kg into 15 meter per second square, which is acceleration, because F equal to ma, acceleration I have to give is 15 meter per second square, which is called 30 kg, I mean 30 into 1 kg into 1 meter per second square. What is 1 kg into 1 meter per second? It is about Newton. Okay, 30 newtons. I have applied 30 newtons force on this 2 kg mass. So let us convert, because the question is to convert this to the lb force. I know 1 Newton is equal to 0.225 lb. Then what about 30 newtons? Is nothing but 6.75 lb force. This is how solution for the problem number 1. And second, okay, what is the lb force acting on my hand if I hold 2 kg iron plate? Imagine I have holded 2 kg iron plate. Now you people are supposed to tell me that how much force is acting on my hand. Okay, then it is very simple, F equal to m into A, that is nothing but m into g, because at rest, my hand at rest, the only force that is acting is because of the acceleration due to gravity. Then A becomes z, and what is mass is 2 kg into 9.8 meter per second square, which is nothing but 19.6 into 1 kg into 1 meter per second. So what is 1 kg into 1 meter per second square? Nothing but 1 Newton. Okay, then 19.6 newtons. Then I know, that means if I am holding this 2 kg, the amount of force that is acting on my hand is 19.6 newtons. Then 1 Newton is equal to 0.225 lb force, that is pound force. The 19.6 Newton means 4.275 lb force. This is how the force, this example is just for the lb force. So you can calculate what is the dyne force required or what is the kg force required. Okay, you can, using the simple conversion formula, you can calculate any force to the Newton force. Okay, or Newton force to the any other force. I hope you understood. Let us go a bit further and calculate the pressure. Okay, it's very simple. Pressure is equal to force by area. So let us solve that example now. So in this example, as we have learned the force, now our ultimate agenda is to calculate the pressure. Okay, now let us do the pressure calculation. Imagine I have some mass with me, I have kept it on my hand. I know the force, now I have to measure the pressure, how much pressure it is putting on my hand, because always the force doesn't count area into play. Once you talk about the pressure, you need to show on what area this one force is sitting. If you calculate that force divided by area on which this particle is sitting, then you can calculate what is the pressure that is on my hand. Currently I am withstanding. So that is what the and what is the pressure acting on my hand, both we have to calculate in 2 units, in Newton per meter square as well as lb force per feet square. Okay, we have to calculate. If I hold 2 kg iron plate with area covered on my hand is equal to 5 centimeter by 5 centimeter. Imagine this is the hand. If you keep on this square one on my particular hand, it is covering some area on my hand. Imagine that area is nothing but 5 centimeter by 5 centimeter area. So if it covers that much area, then what is the pressure on my hand? The solution. The pressure is nothing but force by area. What is the force? M into A by area, because I am holding still. I mean, what is the acceleration that is acting on this particle is z. So the A becomes z. So F equal to mg by area. Okay, the force is equal to ma equal to mg is nothing but 2 kg mass into 9.8 meter per second square, is 19.6 into 1 kg into 1 meter per second square. It is nothing but 1 kg into 1 meter per second square is nothing but 1 Newton. So total force acting on is 19.6 newtons. Okay, what is the area? If it's a square, it's a 5 centimeter by 5 centimeter. I know area is 5 by 5 centimeter square. So 5 centimeter by 5 centimeter, because I have to convert, let us convert into the meter. 5 into 10 power minus 2 meter into 5 into 10 power minus 2 meter. So automatically 25 into 10 power minus 4 meter square, which is equal to 0.0025 meter square. This is the total area on which on my hand on which this mass is sitting. So my pressure is equal to force by area. What is the force? 19.6 newtons, area 0.0025 meter square. That means 7840 Newton per meter square. This is the amount of pressure that is acting on my hand in this area. Okay, force that is acting on my hand in this area, that's called the pressure. And I have to calculate in lb force per feet square also, right? I know 1 Newton is equal to 0.225 lb force. Okay, that means 7840 newtons is nothing but 7840 into 0.225 lb force. Okay, numerator I have got. What is the denominator? It should be in square feet or feet square. 1 meter square is nothing but 10.763 feet square. See, lb force by feet square. Ultimately 163.894 lb force per feet square is the pressure, okay, in terms of pound force per square feet. Here the same thing, if you want to calculate in Newton per meter square, this is the amount of force acting by 2 kg mass, okay, 2 kg mass. I hope now it is clear about the pressure and the force calculations, because it is the important aspect of, as an engineer, that you should know about the unit conversions. So thank you, I hope you have understood. Let us meet in the next lecture.